So next we're going to kind of step back again and we're going to talk about sources of radiation. Where do we get radiation from in our daily lives? Okay. We talked about natural background, but let's just recap this. Natural background comes from the sun, the stars, space in general. It can be terrestrial from our Earth or internal from our own bodies. Again, remember, you are radioactive. Do you guys know what radioactive molecules are really common inside of you? I bet you do when I say it. Ooh, not iron. Iron is a very stable element. But you guys eat bananas, right? Yeah, bananas have potassium, right? There's an isotope of potassium called potassium-40. That is radioactive, and that's in bananas. Okay. You need potassium. Why do you need potassium in your body? Yeah, and it's what allows for your nerve cells to conduct electricity, right? If you recall from learning about the nervous system in the medical assistant class, you need sodium and potassium in your bloodstream and inside your neurons to generate the charge to send a nerve impulse, right? You need potassium on the inside, sodium on the outside, but importantly, you need potassium. Potassium is radioactive. You can actually take a Geiger counter and hold it up to a banana, and it will measure the same amount of radioactivity as the natural background. It is as radioactive as the natural background. Bananas are dangerous. Eat bananas with caution. I'm kidding, they're just fine, but the point is they are radioactive. So there's radiation all around you, ionizing radiation all around you all the time, and we're okay with that. Okay, it's part of being alive. That's natural background. Man-made sources, though, we can limit our exposure to man-made sources, right? You can not be around them, okay? Medical applications. Some you can, some you can't, but medical applications certainly, right? You can limit your exposure to man-made radiation by not getting x-rays unless they're absolutely necessary. This is why, it's the primary reason why we're not just x-raying each other here at the school, because it's not medically necessary. Man-made background radiation from consumer products, from technology, waste, building materials. We'll cover those just a little more in just a little bit. Drinking water. If you zoom in, there are tiny amounts of alpha particles in your drinking water. I forget where this is from. This is Midland, so to Texas, yeah. And you can look up your water reports from anywhere you live, okay. And you can get this list of heavy elements, heavy metals in your water, okay. But look, if you look at gross alpha emitters, 8.2 picocuries per liter of water, okay? That's a teensy amount of radiation, but it's there and it's measurable. You notice what the allowed dose is? It's 20 picocuries per liter. Pico is like the level below nano. It's extremely small. But the point is, there's an amount of radiation in your drinking water. Your drinking water is a little radioactive, but so are you, right? So everything has a little bit of radioactive elements in it. There it is, trillionths of a curie. So it's the next level, next order of magnitude down from billionths, it's trillionths of a curie. So tiny amounts. Remember, 3 Mile Island was 17 curies, right? This is 8.2 trillionths of a curie. So we're talking, again, teeny levels, but it's there, measurable. Natural background dose listed, okay? So we've got 300 microgray, micros for millionths, okay? Coming from cosmic rays, okay? 300. This is the breakdown. Remember, it's 3.5 gray, 3 to 5 gray per year, roughly on average, 3 to 5 milligray per year. We're 300 microgray from cosmic radiation. If you live at high altitudes, you have less atmosphere on top of you, so you're getting more. The higher up you live, so people living in Denver, Colorado, right? They can add on about 700 microgray per year compared to us living down at sea level, or if you live in like the Central Valley, you're living down at, low levels. And there we go, okay? Transoceanic flight crews, they have to go up in that aluminum tube and fly at like 40,000 feet, okay? That aluminum tube is not stopping cosmic rays. Flight crews receive more natural background than we do because they're up in the air. Flying on an airplane is a source of increased natural background radiation. They have to take that into account and just accept that they're going to get more. I don't even know if they're told. Hopefully they're told, but they're getting more natural background just by being up in the air. Add on about 1.7 milligray per year, 1700 microgray. 300 microgray by living near mountains. Terrestrial radiation. You get more the closer you are to mountains. This is things like granite. There are more radioactive sources of things like uranium found in the soil in mountainous regions. For whatever reason, the soil in India, extremely high, 40,000 microgray per year. That's 40 milligray per year, just because the soil in India is more radioactive. City drinking water, as we just said, city drinking water has some. Radon. Radon is a radioactive gas that accumulates in basements. It comes up from the ground. It's coming out from the ground everywhere, but importantly in populations where basements are common, they have to have proper venting. It's actually built into the code of their building code that says they have to have properly vented basements so that radon gas doesn't build up. Radon gas is radioactive, and when you inhale it, it goes into your lungs and stays there. Okay? 1 to 2,000 microgray per year, and that is a large source of natural background. In fact, it's one of the largest sources of natural background that we have under normal circumstances. 400 micrograys of internal radiation, such as potassium-40 from the food that you eat, like bananas, or things like strontium-90, which is a isotope that's in our atmosphere and our water and our food because of nuclear fallouts, because of Hiroshima and Nagasaki, because of any nuclear bombs that have ever been exploded anywhere, and because of things like Chernobyl. Those radioactive elements are going to stay around for forever, and they'll make their way around the entire planet. And so that's going to be inside of us as well. We're part of the planet. So from all non-radon sources, those things add up to about 1 milligray per year. That's one of the 3 milligrays of natural background from all of these things. Radon gas gives us about 1 to 2 milligray per year. So radon gas becomes a bit of a problem. Radon is a byproduct of the decay of uranium. What I haven't told you yet is if you look, you don't necessarily have to look at the periodic table of elements, but it's back there on the wall. Know that there is a periodic table of elements that lists all of the elements, right, periodically. And importantly, when an element decays, it does what's called transmutating. When elements decay and emit radioactive particles, they change into a different element. Because elements are defined by how many protons they have in their nucleus. Okay? Transmutation can either be an element moving up on the table or down on the table, right? Either when it emits a particle, it either emits a particle in a way that adds a proton or emits a particle in a way that loses protons. Transmutation is the movement of an element along the periodic table into a different element. They change into different elements when they decay. Radon is one of the decay byproducts of an element called uranium. Basements are a problem, and they have to be sealed on the floor and then vented properly so radon gas does not seep up through the floor, and vented properly so that the gas cannot accumulate if it does seep up through the floor. There are areas where uranium levels are high, and they're usually in mountainous regions. If you look on this map from the EPA, Environmental Protection Agency, shows deposits of granite, shale, and phosphate, which all are associated with high levels of uranium. And if you look at what is this right here? What is this right there? You guys know that mountain range? Yeah, Sierra Nevada mountain range, right? That's why they're showing high levels here is because it's mountainous. Mountainous regions tend to have higher levels of granite, shale, phosphate, as well as uranium, which is the radioactive element source. But you'll see them in other places too. All these dark areas are where there are high levels of those gas, high levels of those elements, and potentially high levels of radon because of that. And so buildings have to be built in a way that makes it so they vent well. They vent well, so you're not breathing in radioactive gas. You didn't know you had to think about breathing in radioactive gas in your basements, did you? Right? But that's also because we don't live in places where we have basements. And if you ask somebody who lives in the Midwest or something, or lives in these mountainous regions, they probably would answer you, and they probably say, "Yeah, I know about radon gas. Our basement's ventilated for it." But that's a thing we have to think about. Um, that's radon. Good. Let's move forward. So let's summarize those things that we just learned about. Natural background, 300 micrograys cosmic, 300 micrograys terrestrial, 400 micrograys internal, and 1 to 2,000 from radon gas, giving you about 2 to 3,000 microgray, 2 to 3 milligray per year. We need to take a break. I got to give you guys a lunch break. We have plenty more to talk about. If I keep talking, I'm going to wear you guys out. Let's take 30 minutes. Let me go talk.